Hello everyone, I'm back after a long time. So today we have the problem of the day, insert greatest common divisor in linked list. So in this problem we are given the head of a linked list and between every pair of adjacent node, this means this is a pair, this is a pair and this is a pair because otherwise they won't be adjacent. We have to insert a node with value equal to the greatest common divisor of those nodes in that pair. So our first pair is 3, 5. So GCD of 3 and 5 is 1. And for the second pair, GCD of 5 and 15 is 5. And lastly, GCD of 15 and 50 is 5. There is nothing as such tricky about this problem. So we just have to do what we are asked to. So let me tell you an interesting way to find the GCD of two numbers, which I find the most efficient one. If you have a better approach to finding the GCD of two numbers, you can let me know. So consider we are given two numbers, A and B, and we have to find the GCD of A and B. So if we do it the old school way, so let's take the example of 15 and 50 again. How would you find the GCD of these numbers? So we will divide this 50 by 15. And what is the remainder that we will get? So 15 times 2 is 30. And 15 times 3. I'm bad at maths. 15 times 3 is 45 and we will get 5. And this is our remainder. And this was our dividend and this was our divisor. We don't care about this number and this number anymore. We will now divide this 5 by this 15 by 5, and 5 times 3 is 15, and now we have our remainder as 0. So if we have our remainder as 0, this divisor 5 is our answer, and we have seen that GCD of 15 and 50 is 5 because GCD is the greatest common divisor, that is the greatest number that divides both the numbers. So greater than 5 would be 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, and they all don't divide both of them. So our answer would be 5. And we can write a recursive function for this problem, which I will show you in the code. So yeah, let's move on to that part and I will explain the insertion of node that we are doing in the code itself because it's really easy. So let's take a look at the GCD function. Here we have two numbers A and B. If this is a base case, we will look at it later with an example. So first, for every number we will calculate the remainder and then we will call this GCD function. And as we saw for the example, 15 and 50. So our A is right now 15 and B is 15. So our remainder in this case will be 5 because 15 times 3 is 45 and we get 5 as our remainder. Then we will call this function on this 5 and A, which is our 15. So now our A is 5 and our B is 15. So if we calculate our remainder now, our remainder would be 0 because 5 divides 15. And then when we will call GCD function, we will call it as 0 and our B would be 5. And now we hit the base case, which is our A is 0 and we will return B. It's as good as saying when our remainder becomes 0, that is in 15 we go 45, we get our remainder as 5, and then we will take this remainder as the new divisor and the previous divisor would become the dividend. And now 5 times 3 is 15, we will get our remainder 0. We stop there and we will return this answer. So what we are doing is we are just trying to get in the next call and we will hit this base case. Now you may be wondering why this A and B is not checked, which is greater. because otherwise if B is smaller then anything else may happen. But if we look at this, try to do this. If let's say our A was 5, A was 50 and our B was 15, then in this case, we will be trying to calculate the remainder as 50 mod 50. And what this will give us? This will give us our remainder as 15. So now our remainder is 15 and our A in this case is 50. So now we will make a call as 50, this remainder, and A, which is 50. So now in this call, our first A, so our 15 becomes A and B becomes 50. And that's how it is automatically resolving this problem, and we don't need to check if B is greater or not. I have seen this explanation in this video. It will be somewhere on the screen. Okay, so now let's look at this main function, that is inserting the node. So we'll just use an iterator variable which is temp, and while temp next exists. Why we are doing this temp next? Because if we have only single node in our linked list, which is just like let's say 5, there is no pair, so we don't need to check anything, and our temp initially would be here. So temp next is null, so this won't go inside this loop and we'll just return our head. And now if our temp.next exists, that is if we are at any node, let's say this is our linked list, and we are at any node temp and its next node exists, then automatically this will become a pair because we are at temp and its next node exists. So this is a pair and we need to insert our answer, that is our GCD node, in between them. And we are at temp because we know that in a singly linked list, we can insert a node after our current node, and we can't keep track of the previous node as such. So that can be done using variables, but automatically this will be very easy to understand. So now we have a new node which will be the GCD of this current node value, that is of temp dot val, and our temp next val. So this temp, its next node, that is this node, and its value. And so we will calculate the GCD using this GCD function that we just made and talked about for this all time. And now after this node, we have to insert our answer node. So let's say we have created our this is our new node. And first you need to be very careful. First we will check this new node next is equals to temp next. So this initially would have been null because of the constructor. So we will take this pointer and place it at temp's next. So temp and its next node is this node. And so our new node's next pointer is set, and then we will set our temp next pointer at this new node. So we will remove this pointer from here and we will place it on new node from this temp. We can't do this in reverse order because if we do this first, then what will happen is, so let's move back a little bit. So this was our linked list initially. So let's say if you do this statement first, so temp.next is equals to new node. So you place this pointer here, and now you need to point this node to this, the next node in the linked list. And how are you going to do that? Because you have lost track of this node because you have just moved this temp pointer to here. So that's why we need to first place this pointer here and then move this pointer from this position to our new node. And that's how we have inserted a new node between them. And not to mention the updation part, because our temp was here now, and now we need to insert the next GCD node for the next pair. So what has happened is, let's take another example. If we have, let's say, 5 nodes, and you are here and you know that this next exists. So you will insert a node here, and this will be a GCD node, and the pointers will be set initially because it's a linked list again. So our temp is here, and we have inserted this node as GCD here, and now we need to insert a node here. So this node is inserted now, and we need to insert a node here. So we want our temp pointer at this node, at this very node. So we will do temp is equals to temp next. So temp will come here, and again we will have to increase our temp in this iteration itself. So then temp will move here. So that is why it is twice here. And so our temp is now here. So we will insert a node of the GCDs. This arrow would be this way. And then again we'll move our temp 2 times. So our temp will move to this node and then to this node. And then next iteration will start. And let's do it like for all the nodes. So this will here, then our temp will come here. And now again we will insert a node here, and our temp will move at this position. And now for this iteration we will check if temps next exist. And in this linked list we can see temps next does not exist. There is no node after that. That is why we'll break from this loop and we'll return the head. Because we haven't touched head, it is already at the start position. So I hope that we were able to understand this problem really well. So see you tomorrow. Bye bye.